Right. Hello, everyone. So I'm Daniel. Let's see if the slides come up here. There we go. So, right. So first, I want to do like a very honest kind of disclosure. We work with data labeling. I am like blatantly self-serving in the title of this presentation. But I'm going to try and make a pretty good case for why human feedback actually is beneficial when you train these systems. So the tendency is that we all think about how we best can automate everything, and we absolutely should do that, 100%. The question is, what is the sort of efficient combination of different techniques? So I think there's a tendency sometimes to be black or white, like we should just get rid of every human involved in this. And I mean, for companies, that's a great vision. I'm not sure for everyone else, but either way, when you train a system, it turns out that even with very powerful AI, there are very valuable places where you can inject human feedback. So my background is as a robotics nerd. I'm the founder and CEO of Kognic. And I actually spent a formative time when I was younger here in California at UC Berkeley at something called the AMP Lab. So AMP Lab is short for Algorithms, Machines, and People. So already 15 years ago, I did research at AMP Lab on kind of how to balance the power of algorithms, the compute you can apply, and the people involved. So that includes crowdsourcing and those kinds of things. So that was a big part of how I came into this space in the beginning. And just for context, like I firmly believe that everything that moves is becoming autonomous right now. So you'll just have to step out of the hotel to see Waymos everywhere. Most of you may already know that they now crossed 13 million annualized driverless paid runs every year. And it's doubling every 13 months or something right now. So basically, they're about to become a profitable company, essentially. In parallel, we see in China, so Kognic recently opened offices in Shanghai. As much love as I want to send to Europe, learn Chinese is my advice. The stuff that's going on in China is incredibly exciting. BYD is planning to roll out L2+ to more than 4 million cars next year for free. And then in the more distant future, I think robotics is going to come the same way as Waymo now appears to be about to become real. 10 years ago, what is now on the far right might be as real as Waymo is today. And the thing is, we're overflowing with data as a result. So in theory, like a pretty sophisticated, higher-level autonomy car can generate as much as 4 terabytes of data per day. Obviously, most of that is useless and crap, but like there's a lot of stuff flowing in from it. So we forecast about 200 million L2+ cars in circulation by 2030, and that gives hundreds of exabytes of data every day. So if we throw away 99.999% of data, we'll still be generating more data per day than we have for like most of this year, probably. And that's 5 years from now. So like brace yourself. Data is coming. But the problem is we can't trust it. So it turns out that Ilya, actually, the founder of OpenAI, just recently went out and said data is the fossil fuel of AI. So there's only like so much oil in the crust of the earth, and we've sort of dug all of it out. And in language model space, that means we've downloaded all of the internet and trained on it, and like whatever was useful on the internet, we're sort of already in the models now. And the stuff added to the internet appears to be of diminishing marginal value. Basically, it's AI crap now. So like, you need clean signal to learn from. AI cannot learn in isolation. It needs to have signal to learn from. Simulators, great. I love all of my sim friends. But the Matrix is still a movie. Like, you can't download the Matrix on a Docker container and run your car in it. So there are some limitations to simulators. And it turns out, finally, that as much as I hate it as an engineer, if you want to work amongst humans, which these cars do, you kind of need to talk to them. Like, you can't just solve every human problem using physics, as my wife will tell you. So speaking of this, what is growing is compute, right? So better hardware, better algorithms, larger clusters. These huge companies are spending billions and billions and billions on building out massive GPU clusters. But they are not actually getting more data anymore. Like, we only have one internet, and to the point that it's growing, it takes a huge amount of manual effort. So you might think that like LLMs, these language models, are trained in an unsupervised way. That's fucking bullshit. Like, what they are trained on is all of the internet, and we wrote that. We basically labeled the entire internet, if you will. Writing something and putting it online is essentially an annotation task. So they are just piggybacking on like decades or centuries or millennia of annotation, writing things down and putting them online. Had there not been an internet, unsupervised learning would learn nothing. So I think that's important. So speaking of how this has evolved, so I believe that the language model domain is a very good source of inspiration because I think that is the frontier of AI research. So like, as much as we do interesting things in automotive, we're like 20 years behind LLMs, essentially, or 10 maybe, to be kind. If you're in China, maybe 5 years. What happened in language models? So when I started doing this 20 years ago, I was forced to do part of speech tagging. That is a thing in natural language processing where you have to carefully label what every word is in that sentence. Is it a noun? Is it a verb? Is it an adjective? Like, almost no one knows about these things except for a brief period in high school and then they forget, right? This was the core of natural language processing 10, 15, 20 years ago. Since then, this has changed a lot, right? So I think that part of speech tagging is kind of like bounding boxes. It is at some level of abstraction, kind of pixel-wise annotation. Whereas as time has gone by, we have approached a more end-to-end training paradigm in the LLM space, which basically means rather than explicitly labeling all these particles, like part of speech, we're just predicting the next word, right? So transformers are just stochastic parrots, right? They just predict the next token. And this was obviously a result of the emergence of transformers. So attention is all you need is kind of the trigger for all this, where the bitter lesson that Stuart Russell talked about, where like for decades we had these experts doing very careful algorithms and smart things, and every couple of years they were just blown out of the water by people with more GPUs. That's been the trend ever since. And in order for this to work, and this is kind of what's going on inside an LLM, is you need enormous amounts of tokens in order to inform all these probabilities. So every word comes with a lot of context and conditional probabilities that have to be observed out of billions and billions of tokens, actually trillions of tokens by now. So we're going to get to kind of where am I going with this and why is this an automotive thing. Bear with me for a second. So one more point on this, training data sizes. So in the last, like, I don't know, 5, 10 years, the growth of the largest data sets has been absolutely mind-blowing. I mean, we have literally, I learned that OpenAI recently started buying textbooks from education companies in like, they needed all the chemistry books in Spanish they could find. So they put out an RFQ and was like, who can give me all the Spanish chemistry textbooks for ages 10 to 15? Like, the amount of money and time they spend on getting their hands on more data is absolutely mind-blowing. So CapEx in the big six is now at $250 billion per year. Of course, not all of that is AI, but like the big increase since 2021, which is essentially like a doubling, is almost exclusively AI. And we're generating about 150 zettabytes of data per year. So that's like a number no one understands, right? It's one of the ones that you learned about in school that you don't know what it means. Why am I bringing all this up? Well, you get the impression that like we hear about these unsupervised techniques, we hear about all the progress that's being made. Everything, in my opinion, needs to have context, right? So like, what is possible and what is practical in different circumstances? To my understanding, most of you don't have $250 billion to spend every year, or even like probably a fraction of that. So maybe not everyone should use that technique that these companies use. Or if they want to use it, find out a way to get shock and awe amounts of money. And that's where we're going to get to, how do you balance the different costs involved? Because of course you can do extremely powerful things with end-to-end learning and huge data sets if you can spend billions and billions and billions of dollars. And even then, it's not clear that you can guarantee performance. So basically, from a data standpoint, there's obviously volume and quality, and you have different consequences of that. So first of all, not having a lot of data and also having bad data is like the worst, pretty obviously. But if you have a lot of very raw data that isn't very filtered, curated, quality assured, actually the fully loaded cost of that emerges when you also include cloud and GPU and data set management and all these other things. So again, I'm extremely self-serving here. I sell annotation. I am 100% clear that you should not trust me when I say annotation is useful. But I'm trying to make a very honest point here that like, if you look at the total cost of your data operations, of course labeling is expensive, but so are many other things. If you 10x the amount of data and have quality be half as good as it could have been, what is the total cost and how does it compare? Are you actually saving money or are you just moving the problem around, right? That's a legitimate question that I don't think is getting enough attention. So it's very easy to secure funding in large companies to do auto-labeling, right? Which is weird because sometimes it seems to be more expensive than just labeling the stuff in the first place. I don't know if you've done the math, but like I've tried to do the math and I work with almost all the big OEM tier ones now. I'm not sure they're doing this the right way, to be honest. Again, I'm very, very self-serving, but I think it's worth thinking about this. And in reality, the world is very complicated, right? We saw some data from Sweden earlier. Here are animals I just found this morning when I selected in our data set. Like there's freaking reindeer in there. Like there's a lot of weird stuff that you need to figure out how to handle if you are in certain ODDs. And there can be very complex lane grammars and things that will put your product into very challenging situations. What's the most cost-efficient, valuable way to overcome those obstacles? There's also things like shifting distributions. So even if you have a great automation system, how do you make sure that it copes with all the changes in the underlying distributions? So if you're constantly sampling out of the same distribution in the same operational design domain, you can assume your automation system is going to perform pretty well. But as soon as the distributions start changing, you are getting a different distribution of objects, different classes, different weather conditions, and so forth. You're going to see degradation immediately. So then you need to have a solution. And if we, again, turn back to sort of the language model domain, they've come a very long way in figuring out clever ways to efficiently integrate human feedback in their data pipelines. So it's far more sophisticated than just uploading some raw data and having an annotation guideline and then getting data back. Obviously, some of the more publicized methods are like reinforcement learning with human feedback, which is essentially where you have a reward model that you're trying to train in order to predict human preferences. So you're making predictions and maybe planning suggestions, for example. So if you have an automated system that is going to do path planning, how do you understand if the plan is appreciated by a human, right? So this goes back to kind of how has annotation changed? Well, it's less maybe today about pixels and bounding boxes and more about higher level things in the chain of abstraction. So these kind of reward models need human feedback in order to rank and kind of do policy gradients deep into the neural networks. And Anthropic, which is one of my favorite companies, I think has a way to show some of the long-term things we will have to deal with as an industry in the autonomy space. So they talk about helpful and harmless. I don't know what the future will be for autonomy, but there will probably be other trade-offs where we will need to find Pareto optimal boundaries, right? So in language models, you want them to be helpful, right? If you ask a chatbot something, you want it to help you, unless it's harmful. So like if I ask it to plan a weekend in Paris with my wife, you want it to be super helpful. If I ask it to do, cyanide gas in my basement, you want it to be less helpful. That's a challenge that these large AI labs have, is that people will use it for whatever crazy shit you can think of. So you need to guardrail it somehow. Like the example in LA recently where they ordered 6 Waymos into the protests and lit them on fire and used them as a wall. Like, I don't think they saw that coming, necessarily. So that brings us to your question earlier about sort of which method is best here. So, the two philosophies are captured in an image here, right? There is one which I would call kind of move fast and maybe kill people, which is Tesla, at least sooner or later, I guess. It's a very end-to-end heavy approach, still with some intermediate representation. They have occupancy grids and so forth. So it's not fully end-to-end the way they present it, but it's end-to-end heavy. So essentially the philosophy behind Tesla is that if we just get enough data collected and we do enough curation of that, reasonably good driving will emerge from all that data. And the other philosophy is you take a more kind of safety engineering first approach where you have formal verification, simulation, scenario testing, the traditional paradigm of like perception, prediction, planning. To be fair to Waymo, tons of subsystems are deep learning based, so it's not like they are some rule-based PPP policy. It's like extremely deep learning heavy, but it's more modular and more quote-unquote controllable. So these two philosophies, I think, are currently battling it out. And if you're unlucky, you live in a city where you're part of the experiment. But this is essentially the fight that's going on. And I think that this ties back to kind of how to inject human feedback and what type of inspectability you have in your system. So in the end-to-end approach, without clear intermediate representations, it is harder to diagnose, manipulate, impact, change the system. But the price you pay for that is lower performance, probably. Because for every intermediate representation, you lose information, right? You throw away things by forcing it down onto something a human can look at. If you don't throw anything away, you stay in latent space, it's all embeddings and gradients and whatever, you can let all the information flow without any loss. Much more nuanced, much more subtle, but you have no idea what the fuck is going on. Like, you can't send like an 8,000 dimensional vector to court and say, this is what did it. Probably, or at least we're not there yet. So like from a liability standpoint, the downside of end-to-end is you have no idea what's going on. And this is an ongoing experiment. I think it's a philosophical divide. Either way, in the traditional methods, kind of pixels and bounding boxes and so forth are the core. We're now moving more towards curation and coverage. There's a growing amount of like disengagement analysis. So let's imagine you run an end-to-end program, and you plan to train it on all the clips recorded by your fleet. What you quickly realize, and I was in China recently and talked to BYD, they told me that the idea is that you can just learn from all these clips. But it turns out drivers do a lot of weird shit when they're in their car. So many of those clips are not useful, right? Many of those clips maybe have false disengagements where like, oh, the driver grabbed the steering wheel and did something. What happened in this clip? Can we use it? That is essentially becoming now an annotation task where like a human needs to go in and review and say, this was an actual like risk maneuver that we should eliminate from the training data set. Or this was just a driver who was like impatient and wanted to drive a different route and grab the steering wheel. Or, there can be so many reasons why someone did something. They also do, preference analysis. So basically you ask the driver to rate the experience after they're done. But if you have like a 10-minute driving clip and they said it was a terrible experience, why? Like, how do you know why? And no one's going to sit there in their car typing like an IMDb review of their driving experience. Like, you're going to have to do that some other way. Someone's going to need to go in and see what was this like. An example of this that I thought was quite funny is OpenAI has this thumbs up, thumbs down thing on every chat response. So this apparently turned the latest version of their model 4.0 into a sycophant. So a sycophant is like what all CEOs love, right? Someone who just says yes and is like obnoxiously pleasant to you. They're terrible for business, but they're great for your ego. That was essentially what ChatGPT turned into because of this thumbs up, thumbs down. It became totally obnoxious because people just said thumbs up on the like super pleasant, super nice things. Turns out over an extended period of time, that's a terrible experience. So these kinds of problems feel far into the future if you're dealing with pixels and bounding boxes today. But the future will come, and it's already coming in the LLM space. So in the LLM space, this is a here and now problem. Automotive so far has more problems of the part of speech tagging problem nature. We're not quite there yet in the level of abstraction, but it's gonna come. And if you download, for example, DeepSeek's latest papers, you'll see that you can't see all the text probably, but like essentially the pipeline they have built out to maximize performance of their model is incredibly heavily reliant on various kinds of fine-tuning. There's like supervised fine-tuning, there's fine-tuning with, so basically like human inspection and careful curation and careful feedback. The latest now is that you can also do reinforcement learning with verifiable feedback. So you can also have like, for programming tasks, for example, you can have math problems and things that you know how to solve to be another type of like feedback loop for these models. So in automotive, the equivalent, I guess, would be driving scenarios where you've defined what the correct solution is. All these kinds of things are always present together. So as opposed to what I'm hearing when I talk to people in our space, in the LLM space, it seems like everyone assumes all of these things will be part of the pipeline for a very long time. It's not like we were going to get rid of any of these pieces. It's about how do we figure out how to make it kind of Pareto optimal. How do we manage to do massive data collection with heavy filtering? How do we do sort of deduplication? These are LLM examples, but the equivalent can easily be imagined for autonomy data. So like, what's the equivalent of toxicity? What's the equivalent of PII information? What's spam? What's low quality detection? How do you figure out kind of the quality over quantity trade-off? And how do you apply precise human feedback in that process? So I did some quick searches on the plane here, and basically top labs are approaching $1 billion annually in annotation spending. So whenever I meet an automotive customer who tells me they are soon going to be done with labeling, I'm like, are you as good as these guys? Because in that case, I'm surprised, right? Like if OpenAI is spending $1 billion a year on annotating data, what makes you think, we are going to get rid of it? I'm not saying like, if I'm wrong, by all means, I'll do something else. I'm just confused by the fact that in the LLM space, spending is like growing out of control because somehow they seem to think this is the best way to make their models as best as they can be. The fact that we usually talk about how can we eliminate it, I think it's good to have cost pressure and it's good to make me more efficient and all of us more efficient, but ultimately the goal is to deliver a great product, right? So how can you deliver a great product in a sort of Pareto optimal way, where you trade off between GPU, between human labeling, between all the different things that go into the pipeline, simulation, scenario-based testing, etc. So obviously, I need to just give a shout out to what we do in the end here. I think from our perspective, the goal is to maximize productivity, right? So we want to provide the most productive tools we can, the most powerful integrations of auto labels we can, the most scalability we can, because of course it should be as cheap as possible. So in the last year, we have 7x'd our productivity and been able to cut the cost per label in half. So the fact that we are making these price improvements means that the small amount of precisely applied human labeling you need to do is also drastically dropping in price. So I imagine we will be cutting it by about 50% every year for several years. So there are multiple ways to make this efficient. One of them is to just make it radically cheaper as well. So one of my favorite things is where, like, whenever someone says they have an auto labeling system internally, my favorite question is like, okay, send us some sample data from that, and let's see how much ends up in like it's already done, how much ends up in like verification, and how much ends up in adjustment. So if a human goes in and inspects it and they say, all of this is great, we're done, well, then you don't pay anything, then it's fine. If some of it needs verification and like you need to go in and check it, there's a little bit of cost. If you need to start making adjustments, there's a bit more cost, and if the box is missing or whatever the thing is that is missing, comes with a big cost. This is the best way, from my perspective, to figure out how far have you come. Because if you start seeing how data ends up in these different buckets, you get immediate feedback on how well you're doing in your auto labeling, and you can start doing cost math on this. So you can basically say, I'm spending this much on automating it, I'm seeing the distribution shift towards this bucket more and more. Every time I expand my ODD, distribution ends up on the left again, and then I make progress, and I add some driving task, and you go back and forth here. So these are the graphs that I look at. It's like, how much is my customer able to put in automatically locked, that is essentially free? How much ends up on the far left, and how are they improving? So I'm about to finish. I think the point that I'm trying to make is like, if you carefully apply human feedback, it can both increase performance and save compute. And major AI labs combine all of these techniques: supervised fine-tuning, RL with human feedback, RL with verifiable feedback, and they're spending billions on it every year. And better data is, in many cases, far cheaper than more compute, because they are spending many, many more billions on compute than they're spending on data. The factor is probably 5 to 1 or something, maybe even 10 to 1. So if they can spend $100 million more on data and make the data a lot better, they can save that quickly on the GPU side. And I think that's true also for the automotive domain. So thank you for your attention.